All right, our next lesson in this unit on solving systems of linear equations is called Solving Systems of Linear Equations Using Substitution. That's the title for today, so add that to your table of contents and also to the top of the next clean sheet of notebook paper. And then your EQ for today is how can I use substitution to solve a system of equations? Hit pause and set up your notes with your table of contents and your title and EQ, and when you're ready to move on to the notes, hit play. All right, here's your notes for today. This is all the notes, and then we're going to try a couple examples. How can I use substitution to solve systems of linear equations? You guys, this is so fun. I'm excited to be teaching this to you. You can solve linear equations using an algebraic method. That should be singular. There we go. Method called the substitution method. Solve one of the equations for one of the variables, then substitute the expression for the variable into the other equation and solve for the second variable. So our steps here is going to be solve for the first variable, then we're going to plug whatever we get in for the first variable into the other equation and solve for the second variable. We'll write the solution as an ordered pair and then we'll check it. Okay, this will make more sense when we actually try an example. So copy this into your notes if you're not already done copying. When you're ready to move on to an example, hit play. All right, you do not need to copy this. We're just going to look step by step at what to do, and then we're actually going to work one out together. So here is our system, and they're telling us to solve it by substitution. So our system is these two equations, y equals 3x, and then 2x plus y equals 15. Now you will notice that we have two variables, x and y, that we have to solve for. So do you see right here in this first equation, they tell us what y equals. Y equals 3x. And that is so nice of them to tell us that y equals 3x, because what I'm going to do now is take that 3x that I know y is equal to, and I'm going to plug it in for y so that I only have one variable. I'll have x's instead of x and y. Okay, I can't solve for the variable if I have two different variables there, but if I plug in the 3x in place of the y, then I know how to solve that equation. So I'm going to take the 3x and plug it in for y. You can see right here that they did that. Then 2x plus 3x, I just combine those like terms as 5x. And then I know how to solve this little simple equation. 5x equals 15, so I divide by 5 on both sides, and x equals 3. So I know what x is now. That was step 1. Step 2, again, you don't have to copy this. Let's just talk through it together. Step 2, now that I know that y equals 3x, now that I know that x equals 3, I am going to plug in 3 for x. And I can do this in either equation, but I usually look for the easier one. And I think that this one is going to be easier to plug that into. So I'm going to plug in 3 for x. Remember, I got that from solving in step 1. And then I just say, what is 3 times 3? 9. So y is 9. So I know that my solution for this system of equations is x equals 3 and y equals 9. So then we would just write that as the ordered pair, 3, 9. If I graphed these two equations, this would be the point where they would cross. Isn't that cool? The answer is yes, it is cool. And then we can check our solution by plugging in 3 for x and 9 for y, and we should get that they equal each other on both sides. Let's try one. So this is example 1 in your notes. I'm going to do it with you. Get ready to have some fun. Okay, so my two equations in my system are y equals x plus 3 and 2x plus 2y equals 38. So I want to look for which of these equations has already defined what one of the variables is equal to. And in this one, it's the first one. It tells me that y equals x plus 3. Okay, so what I'm going to do is rewrite the second equation, and in place of the y, I'm going to plug in x plus 3. So let's do that. 2x plus 2 times, in parentheses, I'm going to put x plus 3. We're plugging that in for y. How do I know to do that? Because y is equal to that. We see that up here. Equals 38. All right, from here, I see that I need to distribute this 2 so that I multiply each part by 2. So I'm going to get 2x stays the same, plus 2 times x is 2x. 2 times 3 is 6, 38. Next, I can combine these like terms right here and get 4x plus 6 equals 38. I'm going to bring this over here so I have more room. 4x plus 6 equals 38. At this point, we're just doing a two-step equation. So I'm going to subtract 6 on both sides. Bring down the 4x, those cancel, 32. Then I'm going to divide by 4 on both sides. Okay, and x equals 8. Okay, we're halfway there. Isn't this so fun so far? So I've got x equals 8. Now I'm going to erase all this so I have some room to figure out what y is. And this one you can probably figure it out in your head. But let's just get rid of that. Okay, so now I'm going to take either equation will give me the right answer. I like this one because it's easier to work out. I'm going to plug in 8 for x. So in place of this x, I plugged in an 8. What is 8 plus 3? 11. So my solution here is 8, 11. X is 8, y is 11. And we're done. Wasn't that so fun, you guys? Let's do another one. All right, call this example 2 in your notes. They used, instead of x and y, they used p and q. That's totally fine. We still have 2 variables. It's not a big deal at all. Okay, so I see from looking at my 2 equations that this is the one that I'm going to plug into the other. So I know p is equal to 4 minus q, so that is what I'm plugging in for p in my second equation. So I'm going to rewrite the second equation for, in place of p, I'm plugging in 4 minus q. I'm going to try and do a little curly q at the end of the q so we know it's not a 9. Okay, so I plugged in for p right here, 4 minus q. Now I have to distribute the 4. 4 times 4 is 16, minus 4 times q is 4q, plus q, that's 1q, if you remember. All right, now I need to combine like terms. So negative 4q plus, that's 1q, would be negative 3q. So 16 minus 3q equals 1. I'm going to bring this up here. 16 minus 3q equals 1. All right, from here, I'm solving for q, so next thing I need to do is get rid of the 16. Okay, I have negative 3q left over and negative 15. Last thing to do is divide by negative 3. This is a little blast from the past from when we solved equations earlier in the year. And a negative divided by a negative is a positive, and then 15 divided by 3 would be 5. Q equals 5. Okay, so I'm going to write that up here. That's halfway there to my solution. And then I'm going to erase everything so that I can find the other piece of my solution. So I know that q equals 5, so in either equation, I'm going to use the first one. I'm going to plug in 5 for q. What's 4 minus 5? Negative 1. So p is negative 1, q is 5. They told me to write it as the ordered pair PQ. So that would be negative 1 for p and 5 for q. And that's my solution. So if I were to graph those 2 equations, that would be the point where they would intersect. I know y'all are having so much fun with me that you're ready to start on your digits. Okay, 6.4, solving systems of equations by substitution. Have fun.